Hey everyone, this is Andrew. Welcome back to the channel and welcome back to the Organic Chemistry series. In this video, we will be discussing resonance and formal charge. In organic chemistry, resonance is an extremely important topic. Resonance describes the delocalization of electrons in polyatomic ions and molecules that cannot be expressed, or in which the bonding cannot be expressed in a single Lewis formula. Resonance is completely driven by pi bonding, okay? So let's look at this double bond here in this molecule of ethylene, okay? So when we take a look at this, we have to remember that in a double bond, the carbon atoms are sp2 hybridized. They have 3 bonding domains. This sigma bond right here is one bond in the double bond. The other bond making up the double bond is a pi bond. And in a triple bond, it'd be a single sigma bond and 2 pi bonds. So there'd be another unhybridized p orbital on each carbon atom in which the pi bonds can overlap, and that's where the bonding occurs. Okay, so let's take a look at this first example, okay? What we have here is an acetate ion. This acetate ion has 2 resonance structures. In order to understand the formal charge of these atoms in the molecule, let's take a look at the periodic table. So the important atom to look for in the periodic table is the oxygen atom, specifically for this acetate ion. So when we look at the periodic table, we see that oxygen is in group 6A, meaning it has 6 valence electrons. So when it comes to the Lewis formula and the dot structures and the resonance structures, coming back and remembering that oxygen has 6 valence electrons is crucial. So in order to calculate formal charge and what drives the formation of resonance structures is this idea of formal charge and the idea that pi bonds and lone pairs of electrons move and they're delocalized. And so when we look at this one, remembering that oxygen has, on the periodic table, it has 6 valence electrons. It's in group 6A. So this oxygen right here, 1, 2, 3, 4, 5, 6. So it has 6 electrons. So 6 electrons are connected with this oxygen atom in this domain. So when we calculate the formal charge of this oxygen and move forward with both resonance structures, this oxygen atom has a sigma bond and a pi bond, meaning that this oxygen atom has a formal charge of 0. Unlike this oxygen atom where it has 1, 2, 3, 4, 5, 6, 7. So its electron density is negative. It has an extra negative charge. So it has a -1 formal charge. So when we move over and look at this one, we see that the pi bond is no longer with that top oxygen. It is down with the one on the right. So in order to understand this, how this occurred is that this lone pair right here moved and formed a pi bond right here, while this pi bond moved and formed an lone pair, with that oxygen atom, leaving that top oxygen atom with a single sigma bond. Meanwhile, this oxygen atom picked up a pi bond. So those electrons moved and formed a new pi bond. Now, in reality, this structure, this acetate ion, exists as a resonance hybrid. There are no 2 structures of acetate ion. It exists as this resonance hybrid where the delocalized electrons are flowing. They're free flowing between the oxygen atom up top and the oxygen atom down below. So the lone pair and the pi bond are always alternating, and it's just shown as this flow of electrons along the side of the atom, of the polyatomic ion. If we take that resonance hybrid to the next step and we look at its molecular orbital diagram, we can draw a line. It looks like this. Now, I haven't taken inorganic chemistry yet. However, I do have some knowledge of molecular orbital diagrams, and the bonding of the movement of electrons flows along that line, and the unhybridized p orbitals are shifting and the lone pairs are shifting and the electrons are flowing. So in order to get good at these formal charges in resonance, let's look at another example. What we have here is a nitrate ion. This nitrate ion has 3 resonance structures with its resonance hybrid. So just like before, calculating formal charge, you take an atom's valence electrons from the periodic table and you subtract the electrons that are being bonded in that molecule. In this case, the polyatomic ion. So when we look at this oxygen, we see that it has 1, 2, 3, 4, 5, 6. So it's happy. It's got a neutral 0 formal charge. This oxygen over here has a -1 formal charge. That's because it has 7. Its electron density is negative. It's got 1 more negative charge than what it prefers to have. Same thing with this one. It's got a -1 charge as well, and so on. You can do it with the rest of them. Each of these resonance structures, the pi bond is moving, and so, for example, in this one, the pi bond moved. This lone pair moved and formed a pi bond right here, and this pi bond broke and reformed as a lone pair on that oxygen, taking up a new form of electron density. But remember, in life, it exists as a resonance hybrid. There's no 3 separate structures of the nitrate ion. It exists as a resonance hybrid where the delocalized electrons are constantly flowing. Excuse me, that was too big. The electrons are constantly flowing between the oxygen atoms around the nitrogen, and they're constantly flowing and reforming pi bonds. Okay, so before we go, let's look at one example just for practice. Pause the video, calculate the formal charge, and then come back and meet up, and we'll see how you did. So let's start with the nitrogen, shall we? It's got 1, 2, 3, 4, 5. So it's happy. It's got a neutral 0 formal charge. This is because, looking at the periodic table, nitrogen is in group 5A. So it's got 5 valence electrons. So going back to the formula, formal charge, valence electrons minus how many electrons are bonded in the molecule or polyatomic ion. In this case, the nitrogen would have a 0 formal charge. This oxygen atom right here on the left, 1, 2, 3, 4, 5, 6, 7, would have a -1 formal charge, and this oxygen atom would 1, 2, 3, 4, 5, 6 would have a 0 formal charge. If you found this video helpful, make sure to like, comment, and subscribe for more content. If you have any ideas for new videos, comment them down below. Dave and I will look at them as soon as possible, and we can make them happen. Thank you for watching. We'll see you in the next one.